Hi everyone, welcome to Chem 150. This is our very first video in a series of video segments that you will see throughout the course. So it's my pleasure to teach you all, and hopefully at the end of all this you have learned some chemistry. Okay, so before we get started, I do want to take this particular video time, spend a couple of seconds to inform you about something. So starting 21st, you will see two resource sections under each week. Say for instance, week 1, you'll see a primary resource and a secondary resources. Okay, as a student, your job is to get through the primary resources every week. The primary resources contain the necessary in-depth interactive videos, okay, and any other material that I deem is definitely must be read and understood, or if you have questions on those, must be asked, and those will be part of the primary resources. The secondary resources would also contain supplementary videos or other reading materials that I find it helpful, but I don't recommend that you spend a whole lot of time. But you're always welcome to go to the secondary resources if you're unhappy for some reason with the material from the primary resources. So you would see these for just about every week. The secondary resources might not contain my videos, but might contain videos from other people that if you want to supplement your knowledge, you can always go to the secondary resources. So, but your primary resources will contain every material that you need for that week to understand that weekly material in depth. And when you have questions, well, that's where you have most of your questions. And if you can comprehend primary resources that's posted under each week's material, more likely you will be up and ready to take your quiz or your homework. Okay, and as class gets started, I will give you more information on the Skype or Zoom. The school is offering a free service through Zoom, which I find a little bit more helpful than Skype in terms of recording our question and answer session. And so I would probably send out a link to all of you. Just this first time around, I don't think I want to schedule any individual question and answer sessions right away. I think I want all of us to meet once through a Zoom, and I'll probably send you a link and directions and instructions on how to participate in that meeting. It would most likely be on not this Sunday that's coming up, but the following Sunday at the end of week 1. You probably have a classroom conference, a video conference. You can wish to turn off your video button and just listen as an audio and participate as an audio. And I would probably expect also to send you some questions in advance, and we will discuss those questions and answers. Probably at that point you may have already taken your quiz 1, at least one attempt, and probably made some attempt on the homework. So you can ask questions on how you would go about things. So it will be most of a classroom thing, and I would recommend everyone to participate. And if you unfortunately I can record our session and then post that session back on YouTube, which even people that are participating can always go back and look at that video. Okay, with that said, we're going to continue to our week's material. So as you've noticed in the course syllabi that we're going to start with our periodic table understanding, and you may wonder why would somebody start with the periodic table compared to people that may have started in a chemistry class, might have seen unit conversions and significant figures and stuff. For the purpose of this class, I think it's much more important that we start with something that is important. Okay, so starting off, the periodic table has seen two different versions at least. I'm not talking about designs of the periodic table that you see on Google, but the periodic table itself has gone through two different versions. The first one by Lothar Meyer, who was the first person to put these elements in sort of a rudimentary fashion, but he did it based on atomic mass, a word we will come back later in the course. But the modern periodic table, the one we're all used to, most likely, I don't think any of us were born 200 years ago, 300 years ago, 400 years ago. So Anybody that's within 100 years of age most likely would be seeing what you're seeing right now on your screen. This is the modern periodic table. This was developed by Mendeleev, and he's the one that came up with this periodic table. And instead of sorting elements based on their atomic mass, Mendeleev sorted them based on the periodic table, which led to this beautiful looking structure that you see. I mean, we've all hawed when we looked at a building like the Sydney Harbor or the Empire State Building or some other things. We looked at a structure and think that it's just beautiful. So to me, this is just one of those beautiful structures that does not have bricks and stones, but it's much more than a brick and a stone in terms of knowledge development, particularly in the sciences. So the periodic table that we have today in use is based on elements arranged by their atomic number. Again, a term that we will come back and discuss in detail, probably used throughout the course. So atomic number, and Mendeleev is the scientist. Okay, elements, while they are in columns and rows, as you can see, they are grouped based on some larger phenomenon called orbitals. Again, a term we will come back and discuss. And there are four types of orbitals: S, P, D, and F. You heard me right. It's S, P, D, and F. And you didn't hear me say it in any other sequence. I said it twice. I can say it one more time. It is S, P, D, and F. Because that is how orbitals can be arranged, because F as the highest energy, S as the lowest energy. And most of us in school systems have stood up in line for some reason that we probably wonder why. And usually the best way to sort people is from the lowest height order to the highest height order. Person who's 6'8" will be in the last in the line, and the person that's just 4 feet tall will be up in the front. Similarly, S orbital is like that smallest person with the lower energy. F orbital is like Shaquille O'Neal, who's at the very last, okay, with several inches. I don't even know, he may be past 7 feet. It doesn't matter, he's the tallest, so he's got the highest energy. Okay, again, all these terms I don't want you to memorize because we're going to come back to those, but I got to start somewhere, and this would be the nicest place to start. And you also see, at least on a computer screen, these elements all have different colors. Some elements that are grouped together all have some colors. So there's a reason why, and I also have to tell you, please use this periodic table. I posted this particular periodic table on our course page. You are welcome to use any other periodic table once you're comfortable with the course material. But until then, I highly recommend you use this, because this is the only periodic table I could find where, if you could all see, there's on top of each of the columns there's a slash symbol with an integer on one side and a Roman numeral on the other, and that's very, very, very important.